Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, we are going to be going through the grade 12 mathematics paper 1 that was written in June 2021. On this video tutorial, we are going to be focusing on question 2 of this past paper, and question 2 deals with the quadratic sequence. So before we get started with the video tutorial, please make sure that you're subscribed to the channel. You make sure that you give this video a huge thumbs up, and please share the video tutorial with your friends. So without any further ado, let's get started, guys. Okay, question 2, right? We are given a quadratic sequence 72, 100, 120, and 132, right? And question 2.1.1 asks us to determine the nth term of this quadratic sequence, right? So we need to determine the formula for this quadratic sequence, right? So let's get started. Okay, you've got 72, you've got 100, you've got 120, you've got 132, and so on and so forth, right? So we're supposed to take term 2 minus your term 1, which is 100 minus 72 is 28. Okay, your 120 minus 100 is 20, and your 132 minus your 120 is 12, right? So this is your first difference, okay? So now we need to get the second common difference, because when you're working with a quadratic sequence, we know that a quadratic sequence has a second common difference, right? So we need to find that second common difference, and to find the second common difference, you're going to take the 20 minus your 28, which is minus 8, and we're going to take your 12 minus your 20, which is minus 8, right? So this is our second common difference. Okay, and then from here, guys, we will be able to get the formula of your nth term, right? There are 3 equations that you guys are supposed to use to help you get that formula of that nth term, right? The first equation is, you're going to use Tn, which is equal to an squared plus bn plus c, right? So that's the first general standard equation that you're supposed to write down, right? And then from here, guys, we need to determine the value of your A, the value of your B, and your value of your C, right? So how do we determine the value of your A? You use the formula 2A is equal to your second difference, right? Then you use your 3a plus b, which is equal to term 2 minus your term 1. And the last one is a plus b plus c, which is equal to term 1. Okay, so we're going to use these 3 equations, okay, to get your value of your A, your value of your B, and your value of your C, right? So this is the first formula that we're going to use to get our A, and then from there, once you have your A, you substitute it into this formula to get your B, and once you have your B, you're going to substitute the A and the B into this formula to get your C, and from there we're going to substitute the values that we've obtained for your A, B, and your C into this equation, right, to get the formula of the nth term of this quadratic sequence. Okay, so let's get started. Okay, so the first one that I said that we're supposed to use is that 2a is equal to your second difference. Okay, so 2a, what is our second difference, guys? All right, so we found that our second common difference is negative 8, right? So we're going to substitute that value into this formula, and that will help us get the value of our A. So we're going to substitute negative 8, and you're going to simply solve for A by isolating it, and your A is equal to negative 4. Okay, so now that we've got the value of our A, we're going to use our next equation, which is 3a plus b is equal to, we said term 2 minus your term 1. Let us have a look at our term 2 and our term 1. Term 2 minus your term 1 is equal to 28, right? So we're going to substitute that into our equation. Okay, and we found that our A is equal to -4 plus B, which is equal to term 2 minus your term 1, we said is 28, right? And then simply here, guys, we are just going to solve for your B, right? So it's 3 times it by -4 is -12 plus B, which is equal to 28, and then B is equal to 28. We're simply going to move this 12, -12, to the right hand side, and it becomes a +12. So your B is equal to 28 plus 12, which is 40. Okay, so that is your value of your B. And the last equation that we're going to use to get the value of your C, right, is A plus B plus C is equal to term 1, right? What was our term 1? We found that our term 1 is 72, right? So our term 1 is 72. So we are simply going to substitute that 72 into this equation, right? We found that our A is equal to -4. We found that our B is equal to 40. We don't know what the C is. We're looking for the C. And our term 1 is equal to 72. So we're going to substitute that 72 in there, right? And then we are simply going to solve this equation for C, right? So I'm just going to -4 plus 40 is equal to 36, right? So 36 plus C is equal to 72. So your C is equal to 72 minus 36, right? Because we took your 36 to the right hand side. Therefore, your C is equal to 72 minus 36, which is equal to 36, right? Right, so we found that the value of our C is equal to 36, right? So from here, guys, we simply take all the value of A, the value of B, and our value of our C. So we take the value of our A, the value of our B, and our value of our C, and we are going to substitute it into this formula to get, right, the formula of the nth term of our quadratic sequence. So let us do that, right? We said that the general formula is Tn, which is equal to an squared plus bn plus c. So we're going to substitute the value of your A, B, and your C into this formula to get the formula of your nth term of this quadratic sequence. So it's -4n squared plus 40n plus 36. So the formula for our nth term of our quadratic sequence is -4n squared plus 40n plus 36. Next question. A term in the quadratic sequence 72, 100, 120, 132 is equal to the 12th term of the sequence of first differences. Determine the position of this term in the quadratic sequence, right? So let's first start off by understanding what this question is saying, right? They're telling us that we have we are told that there is a term in this quadratic sequence that is equal to the 12th term of the sequence of the first differences, right? So guys, what is the sequence of the first difference? Okay, what is that sequence, right? So if you guys have a look at our sequence here, right? So we had the quadratic sequence 72, 100, 120, and 132, right? Then we found the first difference, right, for this quadratic sequence to be 28, 20, and 12, right? And then we found that the second common difference is -8. So the sequence of the first difference, right, is the 28, the 20, and the 12. So this is our sequence of our first difference, because this is what we got when we calculated the first difference for our quadratic sequence, right? So the sequence of our first difference is this sequence here, the 28, 20, and 12, right? So we are told that a term in this quadratic sequence is equal to a 12th term in the sequence of the first difference. So we need to determine the position of this term in the quadratic sequence. So I'm just going to rewrite this quadratic equation, and what we got. Okay, and we are going to focus on the sequence of the first difference, right? So I'm going to just put a box there, right? Okay, we are just going to focus on what's below the yellow line, which is the 28, the 20, and the 12. We want to just focus on the sequence of the first difference, right? And determine, right, the 12th term of this sequence of the first difference, right? And once we get that term, we will be able to substitute that value that we'll get into the quadratic, the formula of the nth term of our quadratic sequence to get that term that they're looking for, right? So the first thing that we're going to do, guys, we're going to focus on the sequence of the first differences, right? And from here, we're going to first determine the formula for the nth term of our sequence of our first differences. From there, we're going to get what the 12th term on this sequence is equal to, right? When I get what the 12th term of this sequence is equal to, once we get that value of that 12th term, we're going to take that value and we are going to substitute it into our formula that we obtained for our formula of our nth term of our quadratic sequence. And from there, we will be able to determine the term that they're looking for in this question. So now, from here, guys, with the sequence of the first difference, if we just focus on what's below the line, what can we notice is going on here? If we just focus on the sequence 28, 20, and 12, right, and we focus on the common difference that we find there, do you guys agree that this looks like an arithmetic sequence? And because it's an arithmetic sequence, we know that to find the formula of the nth term of an arithmetic sequence, we use the formula Tn, which is equal to a plus n minus 1 multiplied by d, right? And then from here, what is our a? Our a is going to be the first term for this sequence, which is 28, okay? What is our d? Our d is our common difference, which is -8. Okay, so let's just focus on that. Let's get the formula of the nth term for this arithmetic sequence, right? So let's just substitute all the values that I've just given you guys. So it's going to be 28 plus n minus 1 multiplied by the d, which is -8, right? Therefore, the formula for the nth term of our arithmetic sequence is Tn, which is equal to 28 plus, you can simply move that 8 to the front like that, and then it's going to be n minus 1. Okay, so it's going to be 28 minus 8. Okay, I'm going to write it out again, right? And then we're just going to multiply it out. So it's 28 minus 8n, right? Minus 8n plus 8, right? And then we're just going to add your like terms. Positive 28 plus 8 is equal to 36, right? So the formula for the nth term for our sequence of first differences is minus 8n plus 36. Okay, but what is this question asking from us, right? What is this question asking from us? That we are told that a term in the quadratic sequence is equal to the 12th term of the sequence of first difference. So we want the 12th term of the sequence of the first differences, right? So because we've already found the formula of our nth term of our sequence of first differences, what we need to do is just simply substitute T12 into this formula to get what the 12th term is in our sequence of first differences, right? So we're going to substitute the 12 there plus 36, and you find that you get minus 60. Okay, so the 12th term, right? The 12th term in our sequence of our first differences, right? So the term that is in the 12th position in this sequence is equal to -60, right? So from there, once we found this term, we're just going to take this -60 that we've obtained and we are going to substitute it into our quadratic equation, or the formula of the nth term of our quadratic sequence, to be able to get the term that they want. Okay, so I'm just going to rewrite the quadratic equation that we had. The formula for the nth term of our quadratic sequence is equal to -4n 10n squared plus 40n plus 36, right? And we found that the term that is in the 12th position of our sequence of our first difference is negative 60, right? So we're going to take that negative 60 and we are going to substitute it into this equation. So it's negative 60, which is equal to minus 4n squared plus 40n plus 36. And we are just going to solve this equation for n, right? So we're going to simply take this negative 60 to the right hand side. Plus 36 plus 60 is equal to plus 96, right? And then here, guys, we can simply use the quadratic formula to solve for your n, right? So this is your A, this is your B, and this is your C. And you're going to simply substitute all these values into your quadratic formula that I'm going to do in red. N is equal to minus B plus or minus B squared minus 4AC all over 2A. So I'm going to simply substitute all these values into this formula. So it's going to be minus, what is our B? Our B is 40 plus or minus, your B is 40 all squared minus 4. Your A is minus 4 and your C is 96 all over 2. What is your A? It's minus 4. And if you substitute that into your calculator, guys, you'll see that you get your n, which is equal to negative 2, or your n, which is equal to 12. Right? But guys, from here, we know that when you're working with sequences, you can't have a sequence, obviously, it can't be a negative n, right? So that means that this is not applicable, right? So I'm just going to put a scratch there, right? Meaning that the value of n that is okay or that is acceptable is that n which is equal to 12. So okay, so the position of this term in the quadratic sequence, right, is the 12th position. So this term is in the 12th position in our quadratic sequence. Okay, guys, let's move on to the next question. Determine the maximum value of the quadratic sequence. All right, so guys, obviously if they want the maximum or the minimum, then we know that we are supposed to differentiate, right? So we are going to simply take the formula of the nth term of a quadratic sequence, right, which is Tn, which is equal to minus 4n squared plus 40n plus 36, and we are going to differentiate this equation, right, to get the maximum value of this quadratic sequence. Okay, so by differentiating this, right, by differentiating this equation, we will be able to first determine the maximum position, right, or with the maximum position that this value holds in our quadratic sequence, and from there we will be able to substitute that n value, right, into this equation to get what the maximum value of the quadratic sequence is, right? But the first thing we need to do is we first need to differentiate this equation, right? So let's just start off by doing that. So differentiating it, so dtn over dn. So, okay, guys, so from here we are going to differentiate this equation in terms of n, right? So dtn over dn, right? So when you're differentiating, guys, you know that it's going to be the minus 4 multiplied by this 2. So I'm going to do it in red, right? So minus 4 multiplied by the 2 there is equal to minus 8. It's going to be minus 8. And then you're going to be left with n to the power of, I'm going to do it in red, 2 minus 1, right? 2 minus 1 is 1, okay? Plus, okay, 40, right? Here we've got an invisible 1 there, right? 1 multiplied by 40 is 40. And then you're going to have n to the power of 1 minus 1, which is 0, plus, right, that plus 0. Because when you differentiate a constant, it's 0. Okay, so I'm just going to rewrite this out. So it's going to be minus 2n. 2 minus 1 is 1. So I'm just going to leave that there because we know that we've got an invisible 1 there. Plus 40, okay, 1 minus 1 is equal to 0. Anything to the power of 0 is 1. That's why this n falls away. And this is what we will have then, right? Okay. And that is equal to 0. Okay. And then from here, guys, we are simply going to solve for n. So if you solve for n, we know that we're trying to isolate the n. Okay, so we can move the 40 to the other side. So it's going to be minus 40, which is equal to minus 2n. And then we're just simply going to divide by minus 2, simply divide by minus 2. And we find that the n is equal to 5, right? But then how is this going to help us with anything? The question says determine the maximum value of this quadratic sequence. So this tells us that the maximum value of this quadratic sequence is in the 5th position. So we're simply going to take this n, which is equal to 5, substitute it back into this equation to get that value of our maximum value that is in our quadratic sequence. Okay, I'm going to repeat that. So we're going to get that n, which is equal to 5. So the maximum value of this quadratic sequence is in position number 5. We're going to take this n, which is equal to 5. We're going to substitute it back into this equation. And from substituting it back into this equation, we will find what the maximum value of this quadratic sequence is. Okay. Okay. And then I said that we need to substitute it back into our equation. So it's minus 4n squared plus 40n plus 36, right? And then we're simply going to substitute t, which is equal to 5 minus 4, where you've got n, you put the 5, plus 40, where you've got n, you put 5, plus 36. Therefore, we find that term 5 is equal to 136. So the maximum value of this quadratic sequence is 136. Okay. Or guys, you can simply use this formula by thinking of the quadratic function, right? We know that when we're working with the quadratic function, it is always in the form of f of x, which is equal to ax squared plus bx plus c. This resembles the form of a quadratic function, right? And then I said that, guys, you can just simply use the analogy of a quadratic function to help you solve or to help you find the maximum value of this quadratic sequence, right? So let me just do that. Usually with the quadratic function, you use f of x, which is equal to, your a is the 4x squared plus your b is 40x plus your c is your 36, right? And then the first thing, we know that the function is frowning like that, right? So we need to get the turning point, the x value and the y value of our turning point, right? So once we have the x value of our turning point, then we're going to simply substitute that x value into this equation to get the y value, or the maximum value of this quadratic sequence slash function, right? So how do we get the x value? You use the axis of symmetry equation, which is x, which is equal to minus b over 2a. You substitute your minus, what's your b? That is your b. It's your plus 40. What is your a? Your a is minus 4. You simply punch that into your calculator. Okay, so it's minus 40. All right, so you'll have minus 40 all over. Minus 4 multiplied by 2 is minus 8. So it's the same as saying 40 over 8, right? Which is equal to 5, right? So we found that the x is equal to 5. And from here, what do? We simply substitute that 5, right? So we find the turning point of this quadratic function is 5, okay? And then we substitute the 5 into this equation to get what the y value is, which is minus 4, the 5 all squared plus the 45 plus 36. and that will give us the same value that we got, which is 136, right? Okay guys, so you can still use the same analogy of a quadratic function. We know that, okay, for a quadratic function to be a maximum, we know that we're going to have an a that is what, less than 0, which is what we have here, which is -4. And then from there we think, okay, cool, we need to get the turning point. From the turning point you get the x value, and from there we're able to get the y value, and from there, guys, that tells us that the maximum value of this quadratic function is 136, which is the same as the maximum value of this quadratic sequence. So if you don't see the differentiating part, you can also use the analogy of a quadratic function to help you answer this question. Okay guys, let us move on to the next question. Okay, 2.1.4. okay, so this one, it says determine the maximum value of the sequence, right? Guys, this is exactly the same question as the one that we just did right now. All you need to do is determine the general formula of the nth term of this quadratic sequence. From there you can simply differentiate the formula that you will have in terms of n, and then from there you will be able to substitute the value of n into your original equation, or you can simply use the analogy of the quadratic function to help you answer this question, right? So I'm just going to use the one where I'm differentiating. Okay guys, so from here, t2 minus your t1 and t3 minus your t2, t4 minus t3, we found that it is 28, 20 and 12, and then from there we found that it is -8 and -8, right? And then someone will be like, oh, but this is actually the same values that we got like the other one. Let me show you what I mean. Someone will be like, oh, but this is actually the same. And then you'll be tempted to use the same formula. Please do not be tempted, because what is going to change everything is this here. Because from here, yes, your second difference is the same. Yes, your T2 minus your T1 is the same, but your T1 is different. Here, your T1 is 72, but here, our T1 is -23. Okay, so we know that we're supposed to use the Tn, which is equal to an squared plus bn plus c. We're finding the values of a and b. We know that 2a is equal to your second difference, which is -8, right? So your a is equal to -4, right? Next one is 3a plus b is equal to t2 minus t1. All right, so your t2 minus your t1 is equal to 28. So your 3 minus 4 plus b is equal to 28, right? Therefore your b is equal to, you're gonna simply solve this, guys. So your b is 28 minus 28 plus 12 is equal to 40. Okay, so your b is equal to 40, and your c is going to be different, guys. A plus b plus c is equal to term 1, which is -23, right? Your a is -4 plus your b is 40, and you are going to be solving for c. Okay, and you find that your c is equal to -59. And then from here, we are simply going to substitute these values into our formula to get the formula of the nth term of this quadratic sequence, because we can see that we've got a second common difference, so it is in fact a quadratic sequence. So your a is equal to -4n squared plus your b, which is 40n, plus your c, which is -59, right? But we're not done. We need to get the maximum value of the sequence, right? So we've got tn, which is equal to -4n squared plus 40n minus 59. And to get the maximum, we know that we are going to differentiate the tn in terms of n, right? So it's going to be -4 multiplied by 2n plus 40, right? And then plus 0, okay, which is equal to 0. And we are going to solve this for n. So it's going to be -8n plus 40, which is equal to 0. Therefore, -8n is equal to -40 divided by -8 divided by -8. your n is equal to 5, and then we're going to substitute this 5 back into this equation to get what the maximum value of this sequence is going to be. Therefore, if we take t5, we find that the maximum value of this sequence is 41. Okay, and we are done. The last question. Consider the sequence minus 11, 2 sine 3x, and 15. Determine the values of x in the interval 0 degrees to 90 degrees for which the sequence will be arithmetic. Okay, the first clue they're telling us, guys, is that this sequence for which the sequence will be arithmetic, right? And guys, what do we know about an arithmetic sequence? We know that when you are working with an arithmetic sequence, right? For example, we've got negative 11, we've got 2 sine 3x, and we've got 50. Right? We know that when we're working with an arithmetic sequence, we've got a first common difference, right? And that first common difference, okay? First common difference, right? And to get that first common difference, we get it by taking your t2 minus your t1. And by common, what do I mean? Is that when you take t2 minus your t1, the value that you get should be equal to the value that you get when you take your t3 minus your t2, right? I'm going to put the t1s and the t2s here at the top, right? That's term 1, that's term 2, that's term 3, right? So when you take t2 minus your t1, right, the value that you will get should be equal to t3 minus your t2 when you are working with an arithmetic sequence. Okay, so t2 minus t1 should be equal to t3 minus t2. Okay, so what is our t2 here, guys? We're going to simply take 2 sine 3x minus what is our t1? Minus 11, which is equal to what is our t3? It's 15 minus what is our t2? 2 sine 3x, right? And then we are going to solve this equation, right, to get the value of x, okay, in the interval 0 degrees to 90 degrees. Okay, so from here, guys, we are simply going to add our like terms, okay? But actually, let's just remove these brackets first. So it's going to be 2 sine 3x plus 11, which is equal to 15 minus 2 sine 3x, right? And then we're going to add your like terms, okay? So it's going to be 2 sine 3x minus the 2 sine 3x. So this minus 2 sine 3x is going to move to the left hand side, guys. So it's going to be the 2 sine 3x plus 2 sine 3x, which is equal to what are we going to be left with? That plus 15, the 15 and the 11, right? So I'm going to rewrite the 15, okay, and the 11 moves to the right hand side, so it's going to be minus 11. And you're going to have 4 sine 3x, right? Because that's the 2 and that 2. It's going to be 4 sine 3x, okay? Which is equal to 15 minus 11, which is 4, okay? And then you're going to divide by this 4. You're going to divide by 4 on the left-hand side, divide by 4 on the right-hand side, okay? So that it cancels. That and that cancel, that and that cancel. When they cancel, you'll be left with sine 3x, which is equal to 4 divided by 4 is 1. Okay, and then from here, guys, what do we need to do to solve this hard, or it looks hard, but it's actually, it's not hard. Okay, this question here. We've got sine 3x, which is equal to 1. How do we solve this? We simply solve this by letting your 3x equal to theta, right? So if you let 3x to be theta, right, you'll have sine of theta, which is equal to 1, okay? And then we basically going to solve for theta. So theta is going to be, so you're going to press your shift inverse of sine of 1, and you'll find that your theta is equal to 90 degrees. And then remember we said, guys, we let 3x equal to theta, right? So remember we said let 3x equal to theta, and we found that your theta is equal to 90 degrees. So this will be your equation 1, this will be your equation 2, and then you're simply going to sub 2 into 1. Okay, so when you sub 2 into 1, what will you have? You have 3x is equal to 90 degrees. Okay, and then you can simply solve for your x. Okay, so your x is equal to 30 degrees. Okay, so the values of x in the interval for which the sequence will be arithmetic is when your x is equal to 30 degrees. Okay, what is important for you guys to see here is that when you're working with an arithmetic sequence, guys, you need to remember that you always have a first common difference, right? And what does that mean? It means that when you take your t2 minus your t1, that will be equal to your t3 minus your t2, right? And then we literally wrote what I put there by substituting the values that we were given, right? And then from here, guys, what did you do? We just simply solved this equation, right? We solved this equation by isolating your sine 3x on your left-hand side, and we find that your sine 3x is equal to 1. And then, hey, we saw that, okay, now we've got a problem. How do we move forward from this, right? Because I know a lot of students are going to be stuck here, right? From here, guys, you let your 3x equal to your theta, right? And when you let your 3x equal to your theta, okay, we are able to get rid of this complication that is going on there, right? You're going to have sine theta, which is equal to 1, right? And we know that to find the value of theta from here, it becomes easy because you just press shift sine theta, or if you're using the sharp calculator that you've seen in my previous video, you press the second function sine of 1, and we find that the value of theta, right, is 90. Okay, and then from there we simply take the value of theta that we've obtained, right, and you substitute it into your equation, right, where we said 3x is equal to theta, to find what the value of our x is going to be. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.